We are going to introduce the all-important t-tests, the statistical tests that relate to hypothesis testing around means. These will be related to p-values and statistical significance, but I want to review first that we were on the same page with estimation in confidence intervals and how those can be used for statistical significance. If you remember this slide, we talked about for a good amount of time how statistics behave. Specifically, we did how means behave, but you saw that proportions or the difference between two means are also statistics, and they also have their behavior, which we quantified with the standard error and how much they just bounce around due to chance. So we spent a good amount of time thinking about what would happen if you repeatedly sampled over and over and so on. Now we've seen that you can take your single study, your statistic, and say, what does that tell me about the population parameter? We take our statistic, we put our confidence interval around it, and we say it's an estimate of where this truth is. We're going to build on that here to say, let's take this statistic and use it to test some hypothesis about this parameter. So this is called hypothesis testing. Let's just do a quick review. Let's think about that Frisbee example that we had. We heard this conventional wisdom that you could fit 72 ounces of beer, a full six-pack of beer, inside a Frisbee. So we said, okay, let's see if that's true. So we went out and we got a sample of 10 Frisbees, n equals 10. And we calculated the mean, x bar equals 56.5. And we measured the standard deviation, 1.97. And using this, we made a confidence interval for what we thought the parameter would be. What's the value? What is the mean of the all Frisbee, right? The typical Frisbee. So we calculated the standard error of the mean. Remember, that's just the bouncing around of this statistic randomly that you would see. And we saw standard deviation divided by the square root of n. And then we made a confidence interval. All confidence intervals have the same form. Point estimate plus or minus some multiplier times some standard error. Here we saw we are 95% confident that the average Frisbee holds between this, 55.3, and this, 57.7. Then we actually went a little bit further and said when you have a small sample size, and 10 is a smallish sample size, the multiplier, which we used here as 1.96, actually needs to be a little bit larger. And we talked about those t-distributions and how if you use a bigger multiplier, you'll get a confidence interval that has the correct amount of precision. So we want to think about what a confidence interval really is. And again, it comes from this idea that if you had done this study thousands and thousands of times, made a confidence interval each time, 95% of them would actually include the true population mean. So imagine that each study that you do, you would get a different point estimate and you would get a different confidence interval, something like this. And all of them would be somewhere around whatever that truth is, that mu or the population mean. And what a study is just you randomly going in and just grabbing one of those. So the chance that that confidence interval catches that mean is 95%. And we can truly say we're 95% confident that we caught the population mean. We're going to build up on this now and talk about the idea of hypothesis testing and how this relates to confidence intervals and estimation.